I was wondering how specific is IL-1 beta for this effect? So given that it's a pro-inflammatory response that involves NF-kappa B, is TNF involved? Is IL-6 involved in this process, or can replace IL-1 beta?
We have done some experiments with TNF-alpha, but not more than that. We haven't tried any other pro-inflammatory stimulant.
More questions? Okay. I think
Who goes first? Very interesting data. It reminds me several of the studies we've been carrying out in different cell types. And I think one of the possible molecular components that may explain part of the responses you see is the presence of connexin hemi channels. When we block the connexin hemi channels, we don't see any mitochondrial failure induced by interleukin or TNF-alpha, interleukin-1 beta or TNF-alpha.
Yeah, I was thinking about that when you gave your talk, that it would be interesting to see what happens with your inhibitor of the channels.
Right.
In this, specifically in this type of experiment. Yeah, Carlos. Carlos está detrás de ti. Carlos primero, después tú.
No, just a question. The endothelial tissue is is subjected constantly to enormous shear straining, unlike any other tissue in the body. And I was wondering, what role does the regeneration of the tissue play in the damage of bacteria of the endothelium, and whether factors that may be involved in regeneration may actually also be important?
Yeah. Well, indeed, not only that, the production of nitric oxide in the vascular endothelium, which actually keeps the vasculature open, is generated by the constant shear stress that activates the AKT in the cell. That's known and activates the nitric oxide production. In terms of turnover, the turnover in the straight parts of the vascular system is very, very low, even in spite of the shear stress. But those are areas of lower shear stress. But if you go to the branching, then you can see higher turnover of the vascular endothelium. And it looks, there is no definitive evidence that every new endothelial cell that replaces the old one is less efficient compared to the original for reasons that are not very clear at the moment. And in those areas of shear stress is where the atherosclerotic plaques start being generated, because the protective mechanisms are disappearing because of the turnover of the vascular endothelium.
Thank you, Salvador. This probably opens a new therapeutic door, because what you just said is coincident with the first publication just now of the CANTOS study, which is the first study with a monoclonal antibody to treat atherosclerosis, which was positive to decrease vascular endpoints. What do you think of this?
I didn't show all my slides. The next slide after the one I show you was the CANTOS study that was published in the New England Journal of Medicine, showing that anti-inflammatory treatment reduces cardiovascular events. This is a very large study that was done with an antibody, a monoclonal antibody against interleukin-1 beta. If you treat people for a year and a half, 3 different regimes of treatment, they show very clearly that there is a reduction in vascular events due to the anti-inflammatory effect without changing the lipid profile of the people. And there is an editorial that appeared this week suggesting that in the future that's the way vascular disease, at least in diabetes, will be treated with anti-inflammatory therapy. There is also another trial, you probably know, which is not finished yet, with small doses of methotrexate in diabetes to try to see whether it reduces the vascular event. I am convinced that we were going to use anti-inflammatory therapy, some form of anti-inflammatory therapy in the treatment of atherosclerosis, especially related to diabetes.
This is a question of something you did not talk about, but could you tell me, just for me, because I take aspirin every other day, how was the discovery of aspirin and all this achieved? It's a historical question.
Well, the discovery of, if you talk about that, I mean, the aspirin has been used now for, or at least the principle of aspirin has been used for at least 3,000 years. The bark of the salix has been used as a medicine. Well, this is work by Vane. All right, was made because at the time they were doing bioassay experiment, and they found that there was a substance released during anaphylaxis, which they call rabbit aorta contracting substance, which turned out later to be the famous thromboxane A2. And they found by chance that that compound was inhibited by aspirin and aspirin-like drugs. And that led to the experiment that checked whether the generation of products of arachidonic acid were inhibited by aspirin. This is the work in which Sergio Ferreira from Brazil and myself also collaborated in the early 1970s.
Yes. Salvador, very nice talk, of course. What kind of anti-inflammatory drugs would you have in mind?
Well, that's the problem with anti-inflammatory drugs, the long-term therapy, the side effects, which is the problem even with the small doses of aspirin that people take, and that are effective protecting against cardiovascular disease. There is no doubt about that. I think that we will end up using either a different type of anti-inflammatory drugs. The monoclonal antibodies is one possibility, which is being tested now, or even small doses of antimetabolites, as is being tested with methotrexate and things like that. I think aspirin-like drugs are out of question. The side effects are too problematic.
Okay, so one more question.
During diabetes, are there high levels of interleukin-1 beta? What's the source of the vascular damage?
During?
The diabetes.
In diabetes?
Yeah.
Well, the hypothesis was that the increases in glucose are enough to produce vascular damage. We believe that that's not the case. What happens, and this is true, the people who have metabolic syndrome or who have diabetes have a low-grade inflammation. That's now widely accepted. They have circulating levels of cytokines which are pro-inflammatory and so on. And on that inflammatory background is where any other substance, including glucose, acts. My interest now is that it doesn't seem that it's so simple that glucose goes and does something which is unexpected. It seems to be activating the pentose phosphate pathway, not just biochemically, but it might be some gene activation there in the pentose phosphate pathway. I think there is something to be found there that glucose does, which is not simply start entering in large quantities. It does something to the pentose phosphate pathway. That this is what I want to understand.
Okay, so let's thank again the speaker for the nice talk.